Good morning students, this is Junita Mukherjee in SS Public School. Today we are going to start a new chapter of class 9's physics. So this chapter is work and energy. So we are we know the similarity between the work and energy, and we know the similarity between it, because a particular object gains the energy by when we are doing any particular kind of work into it, or we are doing some work done, some work on that particular object, that the object that gains gains some kind of force, that is the energy is being gained in it, and when the object it does the work, that is it loses some kind of energy in it. So this is how the work and energy are interrelated. So work, what is work? Work is a kind of a day-to-day life term which is used in science, and basically it means that a kind of a thing which we are doing, that is what we call work. So I am teaching in the class. This is what called the work itself. So we are doing the duties in the school for teaching the students or teaching the members of the school. That are what we call. That is what we call work itself. So these are called the work itself, and we have so many things depend on this work. Work does not means that standing and doing some kind of gossiping. That is also called yes, it is a form of a work doing, but it is not a work itself in the terms of job itself. It needs some energy to talk also. So it's a kind of a work done by our body itself when we are speaking out, and when we are going from one place to another. It's a kind of a work done which is done by the body itself. That is what we call work. And yes, of course, energy is also needed in this particular work to be done, because the energy is stored in the form of a fat in our body itself, which we have already learned in smaller classes. So here the definition of work is something that we are doing in our day-to-day life, that it can be a physical or a mental labor as work itself. It can be a kind of a play or a game, or it can be a watching a movie. It can be a function that we are doing anything in a particular variety of object. It is a kind of a scientific thing. Scientific concept of work. When the scientific concept of work is being done, that is a bullock cart is being pulled by a bullock. So that is what a kind of a work it has been done. Okay, so work done by a constant force. When a work is being done, first we need to see what is the kind of a work done. So in a work done, there is specifically a force is needed, and this particular force includes the displacement in that particular body. So work done specifically, that is work done specifically, is defined by F dot S, where F is the force itself and S is the displacement. So F dot S is the work done, that is displacement, or you can say work done by a constant force itself. It can be done by F dot S. That is what we call work done by a constant force itself. Okay, now this particular force F is equal to 1 Newton and S is equal to 1 meter. Okay, if it is 1 into 1, so the answer will be 1 itself. So work done by the force will be equal to 1 joule. Okay, because work is measured in joule, so it can be 1 joule. Okay. So this is how the work is being done. 1 joule is the amount of the work done on the object when the force of 1 Newton displaced by 1 meter along the line of action of force itself. So this is how the work is being done. Now energy. Energy is something impossible, impossible without, means life is without energy impossible, because without energy we cannot do anything. Okay, a kind of energy, when we are doing or talking, or we are standing, or we are moving from here to one place to another. So that it requires a kind of energy. So we have in ourselves, in the form of fat, hidden energy in that particular fat itself, that is in the muscles itself. So it's a kind of a thing which we are taking on the part of biology. Okay, whereas we know that sun is the enormous source of energy which gives the energy to the whole universe. Okay, so sun is a major source of energy. It gives the all the life support system is depend on sun itself. Without sun we cannot move, we cannot do our work itself in the daytime, because with the light of the sun we are able to see everywhere where there is darkness. Okay, so this sun is the enormous source of energy, or sun is called the biggest natural source of energy to us. And there are many other forms of energy which are responsible for our work to be done. That the energy processed by the body in the measured in terms of capacity to do work. So capacity then to do work is in the form of energy. That is 1 joule is the energy required to do 1 joule of work. Sometimes a larger unit of energy is called a kilojoule or kg. 1 kg is used, that is 1 kg is equal to 1000 joule itself. Now we have the different forms of energy in our system. Some are chemical, heat, kinetic system, kinetic energy. We have potential energy. We have here electrical energy, light energy. These are the different forms of energy which we are using here. James Prescott Joule was an outstanding British scientist. He had best known for his research in electricity and thermodynamics. Among other things, he formulated a law for teaching of electric current, which was given by him, and verified experimental law of conservation of energy, and discovered the value of the mechanical equivalence of heat. The unit of energy and the work is called joule, is named after him. So after him, the unit of energy and the work is being named out. So this is how the different forms of energy are being given to us. So first form of energy, or we can say the energy, is a kind of a capacity to do work or doing work, is called the energy itself. Without energy we cannot do a single part of our system. That is, we cannot move our system, or we cannot talk, or we cannot walk, or we cannot have any kind of working possible in our whole human system. Without energy we cannot move from one place to another. Without energy we cannot do anything in our life itself. So this is how the energy, different forms of energy are being classified. Now one by one we will move on to the different forms of energy, such as kinetic energy, potential energy, and so on. So here we are moving towards the kinetic energy. That is, kinetic energy is a kind of energy when we are giving a external force towards a particular object, or to the particular object. That is what we call the kinetic energy of the system. That is, when we are pushing a particular chalk from one place to another, we are getting a kinetic energy, or we are giving a force to the chalk. That is what we call the kinetic energy of the system itself. Now in terms of kinetic energy of other forms of equation, we can move on to the form of equation. That is, in section 3 equations are there, and initial velocity, final velocity, and the uniform acceleration, the displacement s. In this particular section we will have a particular small derivation which will tell you the importance of kinetic energy, or how the kinetic energy has been derived. Okay, so let's see this particular thing in the next video. Till then, take care and please read the chapter. Thank you so much.